Review of adding and subtracting polynomials. First, we're going to talk about a couple definitions and review of terms, and the first being a monomial. Now, a monomial is going to be represented by either a real number, a variable, or the product of a real number and a variable, or any combination of those. The key difference between a monomial and a polynomial is that a polynomial is going to be one or more monomials strung together with addition or subtraction. If you look at the two different examples here, the only operations with monomials are going to be multiplication. For example, I could rewrite negative 4z squared as a negative 4 times a z squared. The product is being shown there. When we move to polynomials, we're talking about adding or subtracting. So here we have a monomial x to the 7th, and we are adding it to 2x, and a negative, and then subtracting 3x squared, subtracting 2x, adding x, subtracting 6. So because we are adding and subtracting here, that's going to make it a polynomial. Now, when we talk about polynomials, we can talk about specific types of polynomials, and the first one will be a binomial. Binomials have two monomials strung together, and a trinomial will have three monomials. Now, when we talk about polynomials, the last thing we want to talk about is going to be standard form of our polynomial, and that's going to be when we order our polynomial such that the highest exponent is always listed first. In this given polynomial of 2x squared minus x plus 6, we can see this is indeed in standard form because our highest exponent of 2 is listed first. Let's jump into some examples of adding and subtracting polynomials. Number 1, from 2x squared minus x plus 1, subtract 3x squared minus 9. Our first expression is a trinomial because it has 3 terms, and our second expression is a binomial because it has 2. Both polynomials are second degree polynomials because their highest exponent is a 2. From here, I can rewrite this problem so that I have from 2x squared minus x plus 1, I'm going to subtract 3x squared minus 9. To subtract, we are going to distribute through our negative sign and remove our parentheses. Remember, when distributing, each monomial within the polynomial will receive that negative sign. So I can rewrite my first trinomial here as 2x squared minus x plus 1. Now, when I distribute through that negative, this 3x squared term now becomes minus 3x squared. And when I distribute my negative all the way to my minus 9, that becomes a negative minus 9, which becomes plus 9. To simplify this, I want to find and identify all of my like terms. That means I'm going to be matching up my x squareds, matching up my x's, and also matching up my just plain constants, my numbers. So now I can go ahead and say that a 2x squared minus a 3x squared is going to be equal to a negative x squared. There are no other like terms for my x's, so it just becomes minus x. And then I have a plus 1 and a plus 9, which is plus 10. Making my final solution, or simplified polynomial, as negative x squared minus x plus 10. For number 2, we're not subtracting and there's nothing to distribute. We are simply just adding our two polynomial expressions. For this one, I'm going to focus on looking for and identifying my like terms. So I'm going to rewrite this expression without parentheses since there's no distributing to be done. From here I can identify my like terms. I have e to the third, and down here I have a 19e to the third. Then if I look at my e squareds, I have 3e squareds plus an e squared. When I go to combine my like terms, I have 28e cubed plus 19e cubed, which is 47e cubed. To that, I'm going to be adding 3e squared plus e squared, which is a total of 4e squared. This would be my simplified answer. For number 3, we're going back to subtraction. So I'm going to first start off by rewriting this in a polynomial subtraction, as a polynomial subtraction expression. So from 2a squared b minus a plus b, I'm going to subtract the polynomial negative a squared b minus 3a minus b. For the first part, there's nothing to distribute, so I can just rewrite that as is, as a 2a squared b minus a plus b. For the second part, I'm going to focus on distributing this negative to each term. So I give this negative to the negative a squared b. That turns it into a plus a squared b, since the negative times the negative is a positive. I'm then going to distribute to the second term of my polynomial. And when I distribute my negative through to the negative 3a, it becomes plus 3a. And my last, I'm going to distribute it all the way down to the minus b. When I distribute, I get a negative times a negative b, which is going to be plus b. Next, I want to focus on my like terms. My first term is 2a squared b, and that matches up with plus a squared b. Then I have my a's, my plus 3a, and lastly, I have a b and a b. When I go to combine my like terms now, I'm going to first combine my 2a squared b with my a squared b to get 3a squared b. Next, I'll combine my negative a plus 3a to get plus 2a, and my b plus b to get plus 2b. This would be the final simplified answer of my expression. For number 4, I'm going to start off right with the distribution. I'm going to take this negative and distribute it to my 2a and to my negative 5. When I rewrite my polynomial expression without parentheses, my first polynomial stays the same, and I get 3a squared plus a plus 5. When I distribute my negative through, I get minus 2a plus 5. I can now look to combine like terms. So I have an a squared term and no other a squareds. I have an a and a minus 2a. Those would be like terms. And I have a 5 and a 5. To simplify my polynomial, I will combine my like terms. The 3a squared stays by itself. The a's combine to give me a minus a, and my 5's combine to give me plus 10. For number 5, we can simply drop our parentheses of these polynomials because there's nothing to distribute through. We are adding these, which means we don't need to distribute anything to the second term. So when I rewrite this, I'm just going to rewrite it as is, negative 4s cubed plus 2s minus 3. I'm going to rewrite this as a minus 2s squared just because I don't want to have a plus a minus. So minus 2s squared plus s plus 7. And now I can look for all of those like terms here. So I'm going to start out and look for any s cubes I have. That's my only one, so I can move on to my s squareds. I circle my 1s squared, and then I can look for like terms with my s's, and finally with my constants or my numbers. So now I'm going to go through and write my final simplified expression by combining my like terms. So I start with the reds, no other reds to combine, so it's just going to be minus 4s cubed. Look to my s squareds now is going to be minus 2s squared because there was no other like terms to combine with that. And finally, when I get to my s's, I have to start to think of combining. So I have 2s plus s gives me a total of 3 s's. And a minus 3 plus 7 is going to be plus 4. Getting my simplified solution for my polynomial. For this final example, we can see that our first polynomial expression is not given to us in standard form. It's not a huge deal, but it does make it a little bit easier in the second part when you're looking to combine those like terms. So the first thing I'm going to do is rewrite my first polynomial, part of my polynomial expression in standard form. So I will rewrite it from highest exponent to lowest exponent. That means my 9d cubed is written first, then my squared term of plus 3d squared plus 6d. It's important to watch your signs here and make sure that the signs go along with you when you switch the order. Next, I need to take a look at this minus sign here. I'm going to be subtracting my second polynomial, which means I will be distributing or giving each term a negative that's inside those parentheses. So the 5d cubed gets the subtraction sign first. So that would turn into a minus 5d cubed. The second term, 3d, receives the subtraction sign and turns into a minus 3d. And lastly, the negative gets distributed all the way to my negative 4, making it a plus 4 because of the negative and the negative, plus 4 as the last term. From here I can look to combine like terms. Now because I've put both parts of my polynomial expression into standard form already, it makes it a little bit easier to find these terms. So I start off by circling or boxing out here my d cubes. Next I'll look for my d squareds, and there's only one of those. Then I'll take a look at my d's, 6d minus 3d. And lastly, I can circle my constant all by itself down there. Now when I combine these, I'm looking to combine the likes with the likes. So the d cubes are getting combined. So if I have a negative 9d cubed and I'm going to combine with it a negative 5d cubed, that gives me negative 14d cubed. The yellow box stays all by itself, so I write that as just plus 3d squared. Now I can combine my 6d and my negative 3d to get plus 3d. And then at the end, the 4 is by itself, plus 4. So this would be our final simplified solution to our polynomial subtraction problem, written in standard form.